We built the $10 billion James Webb Telescope to see the farthest corners of the universe. We aimed for the most distant shores of space. But it found the greatest secret of all, right under our noses, on the Moon. Webb focused on a giant crater on the Moon's far side, one shielded from the Sun, and what it found there should not have been there. Geometric remnants on a surface untouched for millions of years. These structures stood right next to a piece of rock, launched from Earth 4 billion years ago. What's more, just a few centimeters beneath the surface was a 70-degree inferno. But the truly disturbing part was this: massive lava tunnels beneath these ruins, despite a surface of negative 170 degrees Celsius, offered a stable 17-degree temperature inside. If you too want to see how this cosmic enigma will be solved, subscribe to the channel, because Jamzold, all your assumptions about the Moon are about to be shattered. We begin now. For years we thought the Moon was a boring, almost dead piece of rock. We believed we knew every square centimeter of it, a dusty, grey, and fully explored satellite, just a faithful companion in the sky. But this assumption was completely wrong. Because robotic explorers like China's Yutu-2 landed in our satellite's backyard, its mysterious far side, and what they saw there forced us to rewrite all the books about the Moon. We now know the Moon is a vibrant world, full of secrets. That's why it all began on an ordinary mission day. Launched on December 7th, 2018, the Chinese rover Yutu-2 was making its way to its target. On January 3rd, 2019, it made history. It achieved the first soft landing on the far side of the Moon. It had landed in the von Karman crater. This location was not far from the South Pole. The rover continued its routine. It moved during the day and went into sleep mode at night. But on the 8th lunar day of the mission, everything changed. The date was July 28, 2019. The control team in Beijing was preparing to put the rover into a midday nap. Because the sun was directly overhead, this meant high radiation and scorching temperatures. This situation could damage the rover. The scientists were examining the last photos from the main camera before shutting it down. And that's when they noticed it. A small crater, filled with a substance that was shockingly different from the surrounding landscape. A jelly-like, shiny thing. This was incredibly strange for the dusty surface of the Moon. It was as if you'd found a handful of colourful jelly in the middle of the Sahara Desert. So, the team postponed all their plans. The entire mission became focused on finding out what this strange substance was. However, this discovery remained a secret for more than a year. Finally, the analyses were completed. This mysterious substance was not alien technology. On the contrary, it was a part of the Moon's own violent past. It's called breccia. Basically, it's a type of rock that melted from an impact and then resolidified. This greenish and shiny sample, found in an area of 20 by 6 centimeters, was a mixture of different minerals. It even contained glass particles. This showed that it had formed at incredibly high temperatures. And because volcanic activity on the Moon had stopped more than 3 billion years ago, so scientists are almost certain a massive asteroid, comet or meteorite created this piece. During the impact, the pressure and temperature rose so high that huge rock masses melted instantly. Some cooled so quickly they turned to glass, the rest cooled more slowly, forming this new rock. This small shiny stone proved that the lunar surface was not calm. It was a dynamic place, constantly being shaped by bombardment from space. But that wasn't the most interesting part. The most interesting part was where this piece was found. Because this discovery was made on the side of the Moon that always turns its back to us. So why do we only see one face of the Moon? Why is the other face constantly hidden from us? The answer lies in a phenomenon known as tidal locking. Our satellite completes one rotation on its axis in exactly 27 days. This period is the same as the time it takes to complete one orbit around our planet. For this reason, it always keeps the same face turned towards us, just like a dancer who keeps their face constantly turned towards their partner while revolving around them. But this doesn't mean the other side is dark. Both sides receive roughly the same amount of sunlight. The side we cannot see is significantly different from the side we do. It doesn't have the dark patches visible to the naked eye at night, the lunar maria, which are basaltic plains. Because these plains were the result of giant volcanic eruptions 3 to 4 billion years ago. Instead, the far side of the moon is covered with countless craters and high mountains. This dramatic difference between the two faces shows that the moon is not a homogeneous mass. In fact, it is a celestial body with two different worlds, one face bathed in seas of lava, the other filled with the scars of billions of years of craters, and this asymmetry is the greatest proof of how chaotic a birth and early period the moon had. So, what other secrets might this chaotic past be hiding beneath the surface? That's why scientists decided to listen to what was below the surface, and what they found exceeded even their wildest dreams. Because they discovered massive caves beneath the lunar surface. These are not ordinary caves. These are huge tunnels, carved out by lava flows billions of years ago. In other words, lava tubes. Although there are no longer active volcanoes on the moon, its surface was once covered with glowing lava. As this lava flowed through valleys, it formed these tunnels beneath the surface, just like subway tunnels on Earth. Only these were created by nature. NASA's Lunar Reconnaissance Orbiter, or LRO, discovered more than 200 such pits. Many of these could be entrances to collapsed lava tubes. Scientists from the University of Trento analysed one of these structures in detail. This cave, located in Mare Tranquillitatis, is about 45 metres wide and 80 metres long, just a little smaller than a football field, and it is located more than 120 metres below the surface. But that's not its most surprising feature. While the temperature on the surface rises to 120 degrees Celsius during the day and drops to negative 130 degrees Celsius at night, the temperature inside these caves is estimated to remain at a constant 17 degrees Celsius. This is an ideal temperature for human life. These caves could be the perfect shelter for future astronauts. Because they provide natural protection against harmful space radiation, extreme temperature swings, and even meteorite impacts. Instead of building a base on the moon, perhaps we could just move inside the moon. So what do we have on the surface? A mysterious jelly-like rock that points to the moon's violent past. A far side we never see, with completely different features. And now, deep beneath the surface, massive caves with a constant temperature that could be our future home. Each of these discoveries alone shakes our understanding of the moon. But when they all come together, they point to a much bigger picture. The moon is not just a satellite, it is a launching pad for our future space exploration. But to make that leap, we need the most basic of resources, and that resource is locked away in the coldest, darkest, and most inaccessible corners of the moon. A treasure waiting frozen in craters that have not seen sunlight for billions of years. This treasure is the key to life and space travel, because frozen in these craters is water. Not just a few drops, hundreds of millions of tons of water, a massive resource mixed into the soil of the moon's polar regions, trapped in microscopic ice crystals. This means a revolution for space exploration, because water in space is more valuable than liquid gold. And this water on the moon could be the key to humanity's expansion into the solar system. That's why the presence of water on the moon changes the entire equation. Because launching a rocket from Earth into space is incredibly difficult and expensive. It requires a tremendous amount of fuel to escape our planet's gravity. For example, more than 90% of the weight of the Saturn V rocket that took astronauts to the moon was fuel just to get off the ground. But the moon's gravity is only 1/6 of Earth's. This means launching a rocket from the moon is much, much easier. If we can extract the ice on the moon and convert it into rocket fuel, our satellite is no longer just a destination. It becomes an interplanetary gas station, a stopover point, a resupply base for spaceships heading to Mars or beyond. Additionally, this water can be used for drinking water for astronauts, and for growing plants in future bases. It can even be chemically separated into oxygen and hydrogen to provide breathable air. It's estimated that the polar regions could hold 1.3 trillion pounds, or about 600 billion kilograms, of water ice. That's equivalent to the weight of 460 million cars. It may not be enough to create oceans. Antoine, it is definitely enough to open the doors to the solar system, wide open. But what if there's something more valuable than water on the moon? What if there's energy itself? Because the lunar soil holds another treasure, one that is almost non-existent on Earth. Helium-3. This is a special isotope of helium, one of the main fuels for the nuclear fusion reactions that power the Sun and other stars. Today's nuclear power plants generate energy by splitting atoms, through fission, and leave behind dangerous radioactive waste. But helium-3 is a perfect candidate for future fusion reactors, because when it enters a fusion reaction, it releases a massive amount of energy, without producing any radioactive waste. This means a clean, safe, and virtually limitless source of energy. So why isn't it on Earth, but is on the Moon? Because helium-3 is carried by solar winds. Our planet's magnetic field acts as a shield, deflecting most of these particles. However, the Moon, with no atmosphere and no magnetic field, has been bombarded by this helium-3 for billions of years. So, its surface soil is rich with this precious isotope. It is estimated that there are more than 1 million tons of helium-3 on the lunar surface. Just 25 tons of helium-3 could meet the entire energy needs of the United States for a year. The reserves on the Moon have the potential to power the entire world for thousands of years. But that's not all. Water and energy. These two alone make the Moon incredibly valuable. However, the Moon may be a much richer treasure chest. Because the asteroids that have struck the Moon over billions of years didn't just create craters, they also deposited their precious metals on the surface. This could trigger a new gold rush era. Metals that are rare on Earth and vital for industry, like platinum, iridium, and palladium, could be waiting for us in lunar craters just a few meters below the surface. Scientists who analyzed more than 6,500 large craters with diameters over 20 kilometers estimate that these craters could hold minerals worth trillions of dollars. While we have to dig kilometers deep on Earth to extract these metals, on the Moon, where there are no erosion processes like wind or rain, this precious cargo has remained almost perfectly preserved at the impact site. This situation is transforming lunar mining from a scientific dream into an economic imperative. But this also raises an important question. Who owns the Moon? The 1967 Outer Space Treaty states that no country can claim sovereignty over the Moon. However, there is a great deal of uncertainty regarding the ownership of resources extracted by private companies. So we have a dizzying picture before us. Underground caves with stable temperatures that could be our future homes. Frozen water resources that will serve as a gas station for interplanetary travel. Clean fusion fuel, helium-3, that could solve the world's energy problems for good. And trillions of dollars worth of precious metals that could transform our industries. All of this lies on and under that grey sphere, which we thought for years was just a dead piece of rock. But what we've discussed so far have been theories and potentials. What are the real findings that prove these theories? What did the team see when they landed on the Moon, when they turned on their cameras, when they started their drills? Because the time for predictions is over, the time for discoveries has begun, and the first shocking finding would come from a completely unexpected place, from the temperature of the lunar soil, and, at that very moment, the predictions ended. Because, when India's Chandrayaan-3 lander touched down on the Moon's South Pole on August 23, 2023, it plunged its thermometer into the soil, and the values it read were impossible. Scientists expected the temperature on the lunar surface to be between 20 and 30 degrees Celsius. But the instrument showed a full 70 degrees Celsius, more than twice as hot as expected. This meant that just below the Moon's surface, only a few centimeters deep in the soil, there was a heat source we didn't know about. Just a few centimeters down, there was a hell that literally melted our theories. This was not just an anomaly. This was the first concrete evidence that the Moon's internal dynamics were far more complex, sudden and active than we thought. Because this heat had to come from somewhere. But from where? Wasn't the moon's core cold and dead? Was this unexpected heat generated by the decay of radioactive elements beneath the surface? Or was there a heat flow coming from the moon's depths? There were no answers. There were only more questions. This discovery overturned all our models of the moon's thermal history. So, scientists were stunned. A single temperature measurement had demolished theories built over decades. But this was only the first of the shocking truths they would find. The real bombshell exploded with the re-examination of rock samples from the Apollo missions. Inside these samples, locked away in a lab in Houston for years, there was a piece that shouldn't have been there. An earthly piece. Inside a breccia rock brought back by the Apollo 14 astronauts. A piece about 2 centimeters wide, composed of quartz, feldspar, and zircon was trapped. These minerals are extremely rare on the moon, but yet they are quite common on Earth. Analyses were performed, and the result was breathtaking. This rock was a full 4 billion years old, and its formation conditions pointed to a water-rich environment about 20 kilometers below the Earth's surface. In other words, this was the oldest Earth rock ever found, and we found it on the moon. According to the theory, shortly after this rock formed, a giant asteroid struck the Earth. At that time, the moon was 3 times closer to our planet than it is today. The impact was so violent that it launched this small piece of rock into space and sent it to the moon. Billions of years later, another impact buried it under the lunar soil, and, eventually, we went and found it and brought it back home. This was an impossible journey, an interplanetary message. Because of this small stone proved how violent a bombardment the young Earth was under, but, more importantly, it showed just how intertwined the fates of the 2 worlds were. And now comes the real shock. Because when we looked beneath the South Pole-Aitken basin, the largest and oldest impact basin on the moon, the gravity data went wild. There was something massive there. Scientists call it a mass anomaly. But that description doesn't do it justice. Buried about 300 kilometers beneath the basin lies a massive metal mass 4 times the size of the state of Connecticut. To write its weight in pounds, you would need to put 18 zeros after the 1. This mass is pulling the entire floor of the basin downwards. And it's strangely altering the gravity in the region. It shouldn't have been there. No theory could explain how such a dense and massive piece of metal could have formed under the moon's mantle. What was it? A dense pile of oxides that sank to the bottom of the magma ocean from the moon's formation period? Or something even more mind-boggling? Many scientists believe it is the iron-nickel core of the asteroid that created this giant basin 4 billion years ago, meaning the moon has been hiding a piece of the very weapon that wounded it, beneath its own surface, for billions of years. This meant the moon wasn't just shaped by external impacts, but also by this massive foreign object inside it. But the secrets the moon held didn't end there. Because just the strangest discovery was about our satellite's colour. The moon was rusting. Yes, you heard that right. Rust, scientifically known as hematite. And, for this reddish iron oxide to form, it needs 2 things, water and oxygen. However, the moon is known as a dry and atmosphereless place. The solar wind constantly bombards its surface with hydrogen, and hydrogen triggers the opposite reaction of rusting, which is reduction. So, the formation of rust on the moon seemed impossible, but it was there, concentrated especially in the polar regions. So how? The answer was again on Earth. Our planet's magnetic field creates a long tail called the magnetotail, and this tail extends all the way to the moon. As the moon passes through this tail during a full moon, the magnetotail blocks 99% of the solar wind. And, even more incredibly, it carries oxygen atoms that have escaped from Earth's upper atmosphere to the moon. The oxygen was there. The frozen water molecules released by dust particles hitting the surface were also there. And so, for billions of years, during every full moon, Earth was unknowingly and slowly rusting its own satellite. Hot soil, a rock from Earth, a buried metal monster, and now, rust. Each of these findings is a revolution in itself. But, when they all come together, they raise a much deeper question. How are we going to explain so many anomalies, so many impossibilities? Because these findings show that the moon is not just a passive observer, it is a living, breathing, changing world just like us. And now we understand that the story of this world is actually our story. Because as every new secret we find, every impossible rock, every anomaly, illuminates not just the moon, but also an unknown part of Earth and our own origins. That's why the discoveries didn't stop. And China's Chang'e 5 mission brought back one of these most surprising secrets in crystalline form. This crystal should not have been there. It was no thicker than a human hair, a transparent, small, and at first glance, insignificant particle. But in December 2020, when the Chang'e 5 probe brought back about 1.7 kilograms of rock and soil samples from the moon, scientists in Beijing found this tiny crystal. They named it Changesite Y, and this was the 6th new mineral discovered on the moon in human history, and the first one found by China. This crystal formed 1.2 billion years ago, during a time when the moon was volcanically active. This in itself was an incredible discovery. But when the International Mineralogical Association analysed and confirmed this crystal, the real truth emerged. Such a composition could not be found naturally anywhere on Earth. It was unique to the moon. But the real importance of this crystal lay in what it held within and around it: helium-3. Because this tiny billion-year-old crystal came from one of the regions most dense with a clean energy source of the future. While just 25 tons of helium-3 could meet America's energy needs for a year, it's estimated there's over 1 million tons on the moon. That's enough energy to power the entire planet for thousands of years. And that tiny, hair-thin crystal stood in a lab as physical proof of this enormous potential. But the moon's secrets were not just hidden in microscopic crystals or massive metal masses. Sometimes, these secrets appealed to our most basic senses, like smell. Yes, the moon smelled like gunpowder, like spent fireworks. When the Apollo astronauts returned to their module after their moonwalks, and the dust clinging to their spacesuits came inside, they were met with this sharp smell. This smell shouldn't have been there. Because there was no gunpowder on the moon, nor anything burning with oxygen. So where did this smell come from? The answer was the lunar dust itself. Because lunar dust is not like the dust we know. It is a mixture of highly reactive, sharp glass particles that have been sitting in the vacuum of space for billions of years in an oxygen-free environment. When these particles came into contact with the pure oxygen inside the module, they instantly underwent a chemical reaction, creating this sharp odor, and this condition, dubbed lunar hay fever, caused sore throats, sneezing, and watery eyes in all 12 astronauts who walked on the moon. This dust wasn't just annoying, it was also dangerous. With its glassy, sharp structure, it scratched the boots of spacesuits, damaged the seals of sample containers, and caused equipment to malfunction. This discovery revealed one of the biggest obstacles to the dream of settling on the moon. That fine, sticky dust that seeps into everything. And so the findings continue to accumulate. The volcanoes of Jupiter's moon, Io, erupting hundreds of kilometers high, the potentially habitable oceans beneath the icy surface of Saturn's moon, Enceladus. Each satellite in the solar system was a world in itself, with its own character. But our satellite, the moon, was different from them all. Because its history was directly linked to our history. Every mark on its surface contained a page from our planet's past. Its resources could shape our future: a rusting surface, underground caves, a buried metal monster, a rock launched from Earth, an unexpectedly hot soil, a new crystal, and a dust that smelled like gunpowder. None of these might make sense on their own. But when they all come together, they show that the moon is much more alive, much more complex, and much more valuable than we thought. We now know what we found, but now we face a much more difficult question. How do all these missions work? What is the technology that allows a robot to go hundreds of meters deep and take a picture of a cave? How does a spectrometer know that a rock millions of kilometers away is rusting? Because behind these incredible discoveries lies engineering that is at least as incredible. And the first step of this engineering achievement is to defeat one of the Moon's most ruthless enemies, that sharp, sticky, and all-corroding dust. So what's behind this? What are the engineering marvels that make such incredible discoveries possible? Because it's time to leave the shocking findings behind and delve into the heart of the technology that brought us these findings. Now, it's time to understand how the instruments on those silent heroes, the spacecraft, work. Let's get into the details, because each device that reveals the Moon's secrets is a revolution in itself. It all starts with seeing. But how can you look meters below the dark surface of the Moon, or into a crater plunged into eternal darkness? The answer lies in the technology used by rovers like Yutu-2, Lunar Penetrating Radar, or LPR for short. You can think of this system like a sonar a boat uses to map the seabed. Sonar sends out sound waves and listens for their echoes to chart the structure of the ground. LPR works on a similar principle, but uses radio waves instead of sound. The rover sends radio waves of specific frequencies beneath the surface. When these waves hit obstacles like rock, dust, or layers of different densities, they reflect back. The receivers on the rover collect these returning echoes. The time and strength of the echoes help us understand how deep the underground structure is and what it's made of. For example, the echo of a signal passing through a layer of loose dust is completely different from a signal hitting a hard rock layer. With this technique, Yutu-2 was able to map the structure up to about 300 meters below the surface, because this was far beyond the depth previous missions could reach, while older radars could only look a few tens of meters below the surface. Yutu-2's LPR was able to penetrate deep into the lunar crust using low-frequency waves. This allowed it to determine that the first 40 meters consisted of layers of dust, soil, and rock, with solidified volcanic rock layers from lava flows billions of years ago underneath. This means being able to read the Moon's geological history layer by layer. This technology works like a geological X-ray machine, allowing us to map the Moon's underground. That's why it was possible for us to discover those mysterious underground caves and buried craters. But sometimes, seeing isn't enough. To understand what something is, you need to touch it, to analyze its chemistry. How do you get the chemical fingerprint of a rock from millions of kilometers away? This is where spectrometers come in. Specifically, devices like the Visible and Near-Infrared Imaging Spectrometer, or VNIS, which was used to analyze that jelly-like substance discovered by China's Yutu-2 rover, or the sulfur found by India's Chandrayaan-3. The principle behind this device is quite elegant. Just as a prism separates white light into the colors of the rainbow, a spectrometer separates the light reflected from an object into its individual wavelengths. Each chemical element and mineral absorbs certain wavelengths of light and reflects others. This creates a unique spectral signature, or a color fingerprint for that element. When Yutu-2 approached that strange substance, it sent light onto it and analyzed the reflected light with VNIS. The device measured the spectrum of the reflected light and recorded how strong each wavelength was. Scientists compared this spectral data with a library of spectral signatures of known minerals. The result was that the mysterious substance was a vitrified breccia containing silicate minerals like olivine and pyroxene. This was concrete proof that confirmed the old impact theory. In the old methods, to understand a rock's composition, you had to bring it to Earth and analyze it in a lab. Now, thanks to this technology, a spacecraft can perform a chemical analysis of a rock millions of kilometers away in seconds. That's why we were able to confirm the presence of elements like sulfur, aluminum, and calcium on the Moon with such precision. And what about something you can't see, can't touch, but can feel its presence, like that giant mass of metal beneath the Moon? How do you find it? The answer lies in gravity itself. NASA's Gravity Recovery and Interior Laboratory, or GRAIL mission, was designed for exactly this. The mission consisted of two identical spacecraft, named Ebb and Flow, following each other in lunar orbit. This duo used a microwave system to measure the distance between them with incredible precision, with an error of less than 1 micrometer. The principle of this system is based on the Doppler effect. Just like the siren of an ambulance gets higher in pitch as it approaches and lower as it moves away, as the spacecraft pass over a denser region of the lunar surface, meaning a region with more mass. The leading spacecraft, for example, Webb, is slightly accelerated by that region's gravity. This causes the distance between the two spacecraft to momentarily increase. When Webb passes that region and flow approaches, the distance decreases again. These tiny changes in distance are detected by frequency shifts in the microwave signals. Using this data, scientists created an incredibly detailed gravity map of the entire lunar surface. And, when they examined this map, they noticed a massive anomaly in the South Pole-Aitken basin. The data showed that there was something much denser than its surroundings beneath the surface. This was like analysing the moon's internal structure layer by layer with a CT scanner. Before Grail, our knowledge of the moon's interior was based mostly on seismic data and theoretical models. But Grail gave us a direct picture of the mass distribution inside the moon. That's why we know about the existence and location of that giant metal mass with such certainty. These technologies provide us with powerful tools to understand the moon's past and its present structure. Radars show the underground, whilst spectrometers read its chemistry and gravity sensors weigh its interior. But the moon isn't just its past, it's also our future. And one of the most important technologies for future lunar missions is the energy systems that will allow us to survive and work there. Solar panels are useless during the long, 14-day lunar nights. That's why NASA is developing a small, compact nuclear reactor for use on the lunar surface. This system, a continuation of the Kilopower project, works on a very simple but effective principle. The reactor produces heat through the fission of uranium-235 nuclei. This heat is transferred to a Stirling engine via a system called heat pipes. The Stirling engine converts heat energy into mechanical energy. This mechanical energy then drives a generator to produce electricity. The biggest advantage of this system is that it has very few moving parts and operates with extreme reliability. The first prototype, about the size of a car, is designed to produce 40 kilowatts of power continuously for 10 years. That's enough energy for about 30 households on Earth. This technology is the key to establishing a permanent base on the moon, conducting mining operations, and running scientific experiments uninterrupted. But all these advanced tools must face one of the moon's most fundamental and brutal realities, its relentless darkness. How does an explorer find their way in a crater plunged into eternal darkness? How can a camera capture details in light 200 times fainter than what our eyes can see? Because the next technology is one that defies the shadows of the moon. Because the next technology is one that defies the shadows of the moon, shadow cam. This is no ordinary camera. This is an eye that can see into the darkness. The craters at the moon's south pole have not received direct sunlight for billions of years. Their interiors are pitch black. The temperatures are even colder than Pluto, dropping to negative 240 degrees Celsius. A normal camera would just see a black screen there, but some shadow cam was designed to illuminate this darkness. Its working principle is similar to how the human eye adapts to the dark. When you enter a room at night, your pupils dilate to gather more light. Shadow cam does exactly that, but on a much more extreme level. With an incredibly sensitive sensor and long exposure times, it collects even the faintest photons of light that a normal camera cannot detect. This light is faint secondary illumination, reflected from the peaks of nearby mountains or indirectly seeping into the crater. Thanks to this, ShadowCam can capture clear images even in light conditions 200 times weaker than what the human eye can see. This is a revolution compared to the standard camera on NASA's Lunar Reconnaissance Orbiter, or LRO. Although LRO's camera has done great work, it was blind in these shadowed regions. ShadowCam eliminates this blind spot. Thanks to it, we can now map the rock structures, slopes, and potential ice deposits inside giant craters like Shackleton for the first time in detail. This technology is a guide that allows us to plan where to land, where to take samples, and which routes are safe in this dark and frozen terrain. It's like a beacon guiding a blind explorer. However, sending something to the moon and making it work is only part of the job. But what if you want to bring something back? Or more importantly, bring people back? This is where HOP technology comes into play. India's Chandrayaan-3 mission not only made a successful landing. On September 3rd, 2023, it reignited its engines, rose about 40 centimeters from the ground, and landed again 30 to 40 centimeters away from its original position. This small hop may seem insignificant at first glance, but it is actually a giant leap for future missions, because it has proven the ability to lift off again from the lunar surface, and this is a fundamental requirement for missions aiming to safely return samples, or more importantly, astronauts, to Earth. The technique behind this maneuver is quite complex. The lander must have engines that produce enough thrust to overcome its own weight, an avionics system to control this thrust precisely, and an attitude control system to maintain stability during re-landing. In the old Apollo missions, a separate ascent module was used to take off from the Moon. This was a more complex and heavier design. The success of Chandrayaan-3, however, opens the way for simpler and lighter mission architectures by showing that a single vehicle can both land and perform a short takeoff. This could allow us to design robotic or human-crewed vehicles that can travel short distances by hopping from one point to another on the lunar surface. This technology is a kind of rocket jumping capability that increases flexibility and mobility on the Moon. Speaking of launching things from the Moon, why not think bigger? Why not launch cargo directly from the lunar surface without using rockets at all? This is where the concept of an electromagnetic catapult, proposed by Chinese scientist Stuhl, comes into play. This system uses the power of electromagnetism instead of the chemical energy of traditional rockets. The idea is similar to an athlete throwing a hammer. Imagine a launch capsule, levitating on a rail system about 1 kilometer long using magnetic levitation technology. This capsule is accelerated along the rail at an increasing speed. When it reaches the end of the rail, it has reached the Moon's escape velocity of 2.4 kilometers per second and is launched into space. The energy for this system can be provided by solar panels and nuclear power. The most incredible part is that the system can recover more than 70% of the energy spent after each launch. The Moon's weak gravity and almost non-existent atmosphere make this technology much more efficient than on Earth. While the cost of launching a rocket from Earth can be thousands of dollars per kilogram, this catapult system could reduce the cost by 90%. The main purpose of this concept is to transport helium-3 or other valuable minerals mined on the Moon to Earth cheaply and regularly. This system could function like a giant cargo slingshot, operating continuously between the Moon and Earth. This isn't just a science fiction dream. China plans to complete the basic components of this system by 2030 and have it fully operational by 2035. This has the potential to revolutionize space logistics, radars, spectrometers, gravity sensors, cameras, hop engines, and catapults. Each is an engineering masterpiece, designed to solve the Moon's secrets and make our presence there possible. They show us the unseen, analyze the untouchable, and make the impossible possible. But beyond all these complex machines and advanced algorithms, what is the truly exciting part of this journey of discovery? What are we looking for with these technologies? This isn't just about collecting rocks and dust. It's not just about finding new minerals. It's about finding the answer to a much more fundamental question. It's about understanding our place in the universe. And now, armed with these tools, we are heading towards the darkest, coldest, and most mysterious corners of the Moon to answer one of the greatest questions in human history. Because, locked in that eternal darkness is not just frozen water, but also the secrets of the solar system's first days, and unlocking these secrets will help us understand not just the Moon, but also how our own planet was formed and how life began. Now the real adventure begins, and now comes the real miracle. Because what we've discussed so far were just the trailers, the tools, the technologies, the potentials. But now, we come to the truths these tools have shown us, to the moments that shook the scientific world to its core, that ripped up the textbooks. The tempo is increasing, breaths are held. Because this is the climax of discovery, the most incredible, most shocking, most epic moments humanity has faced on the lunar surface and beyond. Get ready. Because we're going to a place where the laws of physics bend, where theories are shattered. This is science at its most thrilling. This is the time of the great discovery. It all began with a smell, the smell of gunpowder. But this was no ordinary smell. It was the first scent ever inhaled on another celestial body. the Apollo 11 mission, Neil Armstrong and Buzz Aldrin, after spending 2.5 hours on the lunar surface, they returned to the Eagle module. They took off their helmets, and at that moment, a sharp, metallic odour filled the air. Aldrin described it as burnt gunpowder. Armstrong likened it to the smell of a wet, ashy fireplace. This was impossible. There was no oxygen on the moon. A combustion reaction could not have occurred. So how was this smell possible? Because the lunar dust, exposed to the ionizing effect of the solar wind in the vacuum of space for billions of years, consisted of extremely reactive particles. When these unsaturated particles came into contact with the 100% pure oxygen inside the module, they oxidized instantly, and this sudden chemical reaction created the sharp smell. This wasn't just a strange memory. This was the moment humanity first directly experienced the chemistry of another world. But this experience came at a price. All 12 astronauts who walked on the moon experienced a reaction known as lunar hay fever, sneezing, nasal congestion, a sore throat, because these glassy, sharp particles irritated their respiratory tracts. This was the first sign of one of the biggest health challenges future lunar colonists will face. This smell was the first proof that the moon was not just a piece of rock, but that it had its own active chemistry. But the moon's chemistry wasn't just hidden in its dust. The biggest chemical anomaly was the colour of its surface. Rust, red rust, and this rust was coming from Earth. This sent a complete shockwave through the scientific community. Because the oxygen required to rust the moon was not supposed to be there. The solar wind constantly bombarding the surface with hydrogen should have created an environment that prevented rusting. But India's orbiter, Chandrayaan-1, definitively detected hematite, or rusted iron, at the moon's poles. The amount was small, but it was there. How was this possible? When scientists pieced together the data, an unbelievable picture emerged. During every full moon, the moon passes through the magnetotail, an extension of Earth's magnetic field. This magnetic tunnel protects the moon from 99% of the solar wind. But there's more. This tunnel captures oxygen atoms escaping from Earth's upper atmosphere and carries them a full 385,000 kilometers to the moon. Yes, the Earth was breathing oxygen onto its own satellite. When combined with the frozen water molecules on the surface, the moon's poles began to rust in a slow, billion-year process. This was one of the most incredible and poetic interactions between two celestial bodies. Our planet was shaping its own moon, with a piece of its own atmosphere. This discovery proved that interplanetary atmospheric transfer was possible. This was a revolutionary finding even for our search for life in the universe. Because it meant that a planet's life signatures could be found on the surface of its neighbouring moon. And then the moment came. Perhaps the most chilling moment in the entire history of lunar exploration. July 28th, 2019. China's rover, Yutu-2, was advancing across the von Karman crater on the far side of the moon. The control team took one last look at the images from the main camera before putting the rover to its midday nap. And they saw it. What they saw should not have been there. Inside a small crater, a shimmering, a jelly-like, greenish substance was sitting there. It was completely different from the surrounding grey, so dusty lunar landscape. What was it? An alien organism? A piece of technology? The scientific world searched for the answer to this question for more than a year. Speculation was rampant. Because this substance looked nothing like anything you would expect to see on the moon. Finally, the spectrometer analyses came in. The substance was not biological. But it was no less surprising. It was a breccia that had melted from an impact, then cooled very rapidly and vitrified, but its greenish colour and jelly-like sheen set it apart from other breccia samples. This indicated that the impact that formed it occurred under incredibly high temperature and pressure. It was likely a fragment from the giant impact that formed the nearby Finsen or Alder craters. And this small as 20 centimetre piece had been thrown from that hell and landed in Yutu-2's path. This was the brightest, most colourful evidence of how violent a place the moon is and how many secrets it hides beneath its surface. That green glow was like the ghost of a cosmic catastrophe from billions of years ago. However, the biggest tremor occurred inside the Moon, a full 300 kilometers below the surface. When NASA's twin Grail satellites mapped the Moon's gravity, they discovered a massive anomaly in the data. Directly beneath the South Pole-Aitken basin, there was a giant mass that was distorting gravity in an incredible way. This couldn't be a measurement error. It was too big. The area covered by this metallic mass was approximately 21,800 square kilometers. Its weight was estimated to be 2.18 quintillion kilograms. It's impossible to imagine this number. It was no different from a giant anchor, buried in the Moon's mantle and pulling it down. Scientists were in shock. There was no place for such a structure in the geological models of the Moon. How did this mass get there? The strongest theory is that it is the iron-nickel core of the asteroid that created this giant basin 4 billion years ago, meaning the heart of a giant planet Esimal that struck the Moon is still sitting deep within the Moon's mantle. This was one of the largest impact remnants ever observed in the solar system. This discovery fundamentally shook the theories about the formation of planets and moons, because it showed that an impact not only shapes the surface, but can permanently change the entire internal structure and evolution of a celestial body. That giant mass of metal proved that the Moon is not just a satellite, but also a cosmic crime scene, a smell, rust, jelly, and a buried metal monster. These 4 moments turned everything we knew about the Moon upside down. They showed us that it is not just a silent neighbor. It was a world that was living, breathing, chemically active, and had a violent past. But all these discoveries may point to a much larger, much deeper truth. Because all these anomalies show that the Moon is a much more vibrant place than we thought. What if this vibrancy is more than just chemical activity? What if there is something in the depths of the Moon, in those stable temperature lava tubes, that has been hidden from the world for billions of years? Because the next step is a theory that brings all these findings together and leads us to the most radical question. What is inside the Moon? Just rock and metal? Or something much, much more? Because the combined meaning of these findings pushes us toward a much stranger possibility. That's why it pushes us toward a much stranger possibility. Because the most shocking thing we found on the Moon wasn't metal or crystal, it was a piece of Earth. This is the most incredible travel story in history, and it all began with rock sample number 15076, brought back by the Apollo 14 astronauts in 1971. For years, this rock was considered an ordinary lunar rock. But when it was re-examined in 2019 with advanced analytical technologies, scientists were frozen in their tracks. A 2-gram fragment embedded in the rock did not belong there. It was terrestrial. It contained quartz, feldspar, and zircon. This was a mineral combination almost never found on the Moon. But the real shock was the dating. This particle was a full 4.01 billion years old, and this made it the oldest piece of rock from Earth ever found. But how did it get there? How was this possible? Computer simulations showed that only one scenario worked. About 4 billion years ago, a giant asteroid struck the Earth. The impact freed this small piece of rock from our planet's gravity and launched it into space. At that time, the Moon was 3 times closer to Earth than it is today, only 128,000 kilometers away. This rock reached the Moon in a few days and crashed into its surface. It remained there for billions of years. It was buried under the soil by other impacts. Until, in 1971, Alan Shepard and Edgar Mitchell found it and brought it home. And this was the first and only terrestrial meteorite ever found in human history. This discovery not only proved the exchange of matter between 2 worlds, it also showed how violent the early solar system was, a cosmic game of billiards where planets attacked each other with rocks. That little stone was a photograph from our own planet's childhood, and we found it on the most unexpected page of our family album, on the Moon. But beneath the lunar surface were not just traces of the past. The key to the future was there too, and this key was inside a cave, a lava tube. Scientists had suspected for years that there might be lava tubes on the Moon. But In 2017, when data from Japan's Kaguya and NASA's Grail missions were combined, the suspicions turned into certainty. A massive void was detected hundreds of meters below the surface in the Marius Hills region. This wasn't just a tunnel, this was an underground cathedral. It was estimated to be about 50 kilometers long and 1 kilometer wide. You could comfortably fit a large city like Philadelphia inside it. This was 10, even 100 times larger than the largest known lava tubes on Earth. How was this possible? Because the Moon's low gravity had allowed for the formation of much larger and more stable lava tubes than on Earth. Billions of years ago, as flowing lava rivers formed a solid crust on the surface, the hot lava underneath continued to flow, carving out these massive voids. This was not just a geological marvel. This was an invitation for humanity's future in space. These tubes offered a stable temperature of 17 degrees Celsius. They provided a perfect natural shield against harmful cosmic radiation, micrometeoroids, and the extreme temperature swings on the surface. This meant that instead of building future lunar colonies on the surface, we could establish them inside these giant natural shelters. This discovery moved the dream of settling on the Moon from science fiction into the realm of engineering planning, lunar rock. But when it was re-examined in 2019 with advanced analytical technologies, scientists were frozen in their tracks. A 2-gram fragment embedded in the rock did not belong there. It was terrestrial. It contained quartz, feldspar, and zircon. This was a mineral combination almost never found on the Moon. But the real shock was the dating. This particle was a full 4.01 billion years old, and this made it the oldest piece of rock from Earth ever found. But how did it get there? How was this possible? Computer simulations showed that only one scenario worked. About 4 billion years ago, a giant asteroid struck the Earth. The impact freed this small piece of rock from our planet's gravity and launched it into space. At that time, the Moon was 3 times closer to Earth than it is today, only 128,000 kilometers away. This rock reached the Moon in a few days and crashed into its surface. It remained there for billions of years. It was buried under the soil by other impacts. Until, in 1971, Alan Shepard and Edgar Mitchell found it and brought it home. And this was the first and only terrestrial meteorite ever found in human history. This discovery not only proved the exchange of matter between 2 worlds, it also showed how violent the early solar system was, a cosmic game of billiards where planets attacked each other with rocks. That little stone was a photograph from our own planet's childhood, and we found it on the most unexpected page of our family album, on the Moon. But beneath the lunar surface were not just traces of the past. The key to the future was there too, and this key was inside a cave, a lava tube. Scientists had suspected for years that there might be lava tubes on the Moon. But in 2017, when data from Japan's Kaguya and NASA's Grail missions were combined, the suspicions turned into certainty. A massive void was detected hundreds of meters below the surface in the Marius Hills region. This wasn't just a tunnel, this was an underground cathedral. It was estimated to be about 50 kilometers long and 1 kilometer wide. You could comfortably fit a large city like Philadelphia inside it. This was 10, even 100 times larger than the largest known lava tubes on Earth. How was this possible? Because the Moon's low gravity had allowed for the formation of much larger and more stable lava tubes than on Earth. Billions of years ago, as flowing lava rivers formed a solid crust on the surface, the hot lava underneath continued to flow, carving out these massive voids. This was not just a geological marvel. This was an invitation for humanity's future in space. These tubes offered a stable temperature of 17 degrees Celsius. They provided a perfect natural shield against harmful cosmic radiation, micrometeoroids, and the extreme temperature swings on the surface. This meant that instead of building future lunar colonies on the surface, we could establish them inside these giant natural shelters. This discovery moved the dream of settling on the Moon from science fiction into the realm of engineering planning. However, the Moon was not just offering us shelter, it was also holding up a mirror to us. And one of the strangest reflections we saw in this mirror was that the Moon was rusting on its own. It sounds like something out of a science fiction novel, but it was true when India's Chandrayaan-1 orbiter detected the presence of hematite, or iron oxide, in the Moon's polar regions. The scientific world was stunned. Rusting required oxygen and water. On the Moon, neither was abundant. Moreover, the hydrogen in the solar wind, which constantly bombards the surface, was a reducing agent that prevents rust. What solved this impossible equation? The answer was 385,000 kilometers away, at home. During every full moon, as the Moon passes through Earth's magnetic tail, oxygen atoms leaking from our planet reach the Moon. This oxygen, combined with frozen water particles on the surface and water molecules released by micrometeoroid impacts, has been slowly rusting the Moon for billions of years. This was one of the most delicate and poetic connections between two celestial bodies. The Earth, without realizing it, was adding a brushstroke to its own moon in space every month. This discovery proved that interplanetary atmospheric transfer was not just a theory, but an observable reality. This had profound implications even for our search for life in the universe. Because a planet's biological signatures could be transported to the surface of its neighboring moon and fossilized there. The rust on the Moon was perhaps the oldest, most distant echo of life on Earth. All these discoveries, each a revolution in its own right. But when they all come together, they reveal a much larger, much more unsettling picture. The Moon was not a dead piece of rock. It was active, dynamic, and in a complex relationship with Earth. So what did this mean for us? Amidst this heap of shocking findings, dizzying numbers, and shattered theories, where is our place as humans? So far, we have focused on the what and how questions. What do we find? How do these technologies work? But now it's time to stop and think. Now it's time to see how all these discoveries affect the deepest, most fundamental question. So what does this mean for us? Because the journey from this point on will be a philosophical one, not with telescopes or probes, but with the mind. Because the Moon is showing us not just the universe, but also ourselves, and what we see in that mirror may be far more surprising than all the rocks and metals we've found. Because now is the time to understand that the greatest discovery is ourselves. But what kind of discovery will this be? A salvation or a tragedy? And now we ask ourselves, these incredible discoveries, these shattered theories, this dizzying journey, what does it all mean for us? It's time to hold our breath and slow down. Because the Moon doesn't just offer us scientific facts, it holds up a philosophical mirror, and what we see in this mirror is filled with a contradiction that is both painful and magnificent. Now, it's time to set aside the excitement of discovery and dive into the silent depths of existence. Because the greatest lesson the Moon teaches us is perhaps to confront the most fundamental paradoxes about our place in the universe. Here is the first paradox. The Moon shows us both how close and how far we are at the same time. On one hand, the Moon is the most familiar object in the sky. It's there every night, a companion that has inspired poets throughout human history, been a confidant to lovers, and determined our calendars. It's only 385,000 kilometers away, practically a cosmic neighbor. With our technology, we can touch it, land vehicles on its surface, and even leave our footprints. This closeness gives us a sense of control and understanding. But, on the other hand, the Moon also represents the beginning of an unreachable void. It is a gateway to the rest of the solar system, to billions of kilometers, to countless worlds. Its silent surface is a constant reminder of the vast, indifferent, and largely empty space that surrounds us. There is a tragic truth to this situation. Even though we can go to the Moon, this journey actually shows us how limited we are. Even with our fastest rockets, it takes days to get there. It takes months to get to Mars, and tens of thousands of years to reach the nearest star. Every step we take on the Moon smacks us in the face with how small a playground we are trapped in. We are like children playing on the shore of a vast ocean, able to collect only a few pebbles. The depths of the ocean, its mysteries, and its vastness are beyond our imagination. This is a melancholic acceptance of humanity's fragility and insignificance in the face of the universe. But a beautiful truth blossoms within this tragedy. Because, yes, we're physically limited, but our minds are limitless. Our bodies may be chained to this planet, but our curiosity can reach the stars. Even if we can't physically go to the moon, we can study its craters with our telescopes, analyze its soil with our probes, and most importantly, reflect upon its existence. Proximity gives us the power to touch and analyze. Distance gives us the inspiration to dream and wonder. What the moon teaches us is that we possess a consciousness that can transcend our physical existence. This consciousness is one of the rarest and most precious things in the universe, and this transforms the sorrow of our smallness into a joy of understanding. You experience this paradox every day too. On one hand, you're at the center of your own life, your own world. Your joys, sorrows, and dreams are very close and real to you. But, on the other hand, when you read the news or look up at the sky, you realize you're just a small part of a huge world with billions of other people, countless other lives. This creates a feeling of both loneliness and connection. The moon takes this personal experience to a cosmic scale. It is both as familiar as a lamp in our home and as mysterious as a galaxy. And to understand this duality is to understand what it means to be human. The second paradox is about time. The moon offers us both eternity and the moment at the same time. The craters on its surface are silent witnesses to a history of billions of years. The moon has barely changed since it formed 4.5 billion years ago. Since it has no atmosphere and no erosion, it still bears the scars from the early days of the solar system. It is a museum where time is frozen. When we look at it, we don't just see a celestial body. We see the childhood of the universe, the formation of planets, a violent and chaotic past. This is a sense of eternity that challenges the human mind. But, on the other hand, every visit we make to the moon, every discovery, emphasizes how fleeting and precious a moment is. The launch of a rocket, the landing of a vehicle, the first step taken by an astronaut. These are short, bright moments that echo in billions of years of silence. The tragic truth of this situation is how meaninglessly short our existence is on this cosmic calendar. If the universe's 13.8 billion year history were compressed into 1 year, recorded human history would correspond to the last few seconds of the last minute of the year. The 50-year-old footprints we left on the moon's billion-year-old surface are less than a grain of sand. One day when we are gone, these footprints will also be erased, and the moon will return to its billions of years of silence. This is a deep sadness brought by the transience of our existence, and the fact that we will eventually be forgotten. But a beautiful truth shines within this sadness. Yes, we are transient. But this transience gives incredible value to the moment. The beauty of a flower comes from the fact that it will wither. The magic of a sunset comes from knowing that darkness will follow. Our existence is exactly like that. The fact that we exist for a brief moment in the infinite flow of the universe, that we can consciously experience this moment, is a miracle. We are the only species that can look at the moon and understand its age, that can comprehend our own transience. This awareness takes us from being a passive observer of the universe to an active participant. That brief moment is filled with meaning, because we give it meaning. You experience this paradox in your own life too. While feeling trapped between the memories of the past and the plans for the future, you know that the only thing you actually have is now. Your birthdays remind you both of how much time has passed and how precious the remaining time is. The moon places this personal perception of time on a universal plane. It reminds us both how deep the past is and what a miraculous gift the present moment is. And it asks us, what will you do with this fleeting, precious moment? The third, and perhaps most poignant paradox, is that the moon shows us both how alone we are and how connected we are to each other. The surface of the moon is sterile, silent, and desolate. There is no life there. This is a stark reminder of how hostile most of the universe is to life. This cosmic silence brings to mind the unsettling question of the Fermi paradox. Where is everybody? Given that the universe is so vast and so old, Why haven't we heard a signal from another intelligent life form? The emptiness of the moon embodies the possibility that humanity might be alone on a cosmic island, in a vast ocean of silence. This is a heavy sense of loneliness that weighs on human shoulders. The tragedy of this loneliness is how weak our hope of being part of a universal family might be. But, right in the middle of this deep feeling of loneliness, the most unexpected and beautiful truth emerges, and that is what we see when we look at Earth. As the Apollo 8 astronauts realized when they took that famous Earthrise photograph, there was only one place hanging in that dark void, that pale blue dot, and everyone on that dot, with all their joys, sorrows, wars, and loves, was inside that small, fragile ship. By showing us that we might be alone in the universe, the moon actually made us understand how connected we are to each other on Earth. Borders, flags, religions, and languages become meaningless when viewed from that distance. All that's left is us. You're also within this paradox. Sometimes you may feel misunderstood, lonely. But then, when you touch a friend's shoulder, hear a family's laughter, or become part of a community, you feel those deep connections. The moon reminds us of this bond. It is a reference point that shows how insignificant all the differences that separate us are in the face of the vastness of the universe. It teaches us anew what home means, and this is perhaps the most precious gift of our journeys to the moon: proximity and distance, eternity and the moment, loneliness and togetherness. These paradoxes are the reflections in the mirror the moon holds up to us. But these reflections don't just show where we are, they also question where we can go, and what kind of species we will be on that journey. Because the potential the moon offers brings with it a new set of paradoxes, a new set of challenging questions. That's why we have to face this dilemma. Because the moon isn't just holding up a mirror to us, it's also presenting a testing ground for humanity's greed, wisdom, and ability to cooperate. The helium-3 on the moon could solve all our energy problems. But it could also start a new Cold War over this resource. Countries and private companies are already racing to control this trillion-dollar treasure. This is both an opportunity that can unite us and a threat that can divide us even further. That's why going to the moon is not just a technological issue, but also an ethical and political one. This situation leads us to a fourth paradox: the pristine, virgin nature of the moon and our urge to transform and domesticate it. The moon has barely changed for 4.5 billion years. It is an untouched archive from the early days of the solar system. Every crater on its surface, every rock, tells a story of billions of years. It is a cosmic archaeological site. For scientists, the preservation of this pristine state is priceless. Because as some regions of the moon are so quiet and so protected, that they could be perfect observatories for listening to the faintest signals from the universe. But here is the tragic truth. It is not in our nature to touch nothing. We change every place we enter. Our footprint on Earth is the greatest proof of this. When we permanently settle on the moon, when we start mining, we will inevitably change that pristine landscape. We will kick up dust. We will dig up the surface. We will make noise with our machines. We will break the silence of billions of years. This is the inevitable price of exploration. But the beautiful truth is hidden within this price. Perhaps it is our destiny to transform the moon. Perhaps it is our mission to bring life to that lifeless world, to melt that frozen water and grow plants, to light up those lava tubes and build cities. Perhaps the purpose of the universe is not for life to be trapped on a single planet, but to spread. The moon could be the first step in this expansion, and the pristine nature we lose in this process is perhaps the price we pay for the blossoming of a new kind of beauty, life, and consciousness. You're also a part of this dilemma. You also experience this internal conflict. You want to both protect nature and benefit from it. On one hand, you admire the beauty of an untouched forest. On the other hand, you live in a house made from the trees of that forest. The moon takes this conflict to a cosmic level. Should we preserve it as a museum, or should we use it as a resource for our future? There is no simple answer to this question, and this brings us to the final and perhaps most important contrast: the act of flying to the moon itself. On one hand, this is the pinnacle of human intelligence and achievement. On the other hand, It is a reflection of our failures on our own planet. The technologies we developed to fly to the moon are the most concrete proof of what humanity can achieve. It requires hundreds of thousands of people to work together for decades. Incredible planning, precision, and courage. The launch of a giant rocket like the Saturn V is a poem written in fire by the collective will of humanity. This is our best side, our curious, exploring, boundary-pushing side. However, the tragic truth also lies here. Is it possible that part of our motivation to go to the moon stems from a desire to escape the problems we've created on Earth? Climate change, resource scarcity, pollution. How ironic is it that we're searching for a new home while making our own planet uninhabitable? Isn't thinking of a Mars or the moon as a plan B an admission of how much we have failed at plan A, which is taking care of our own home? This is a sad thought, but the beautiful truth is that this escape also holds the potential for a solution. The closed-loop life support systems, recycling technologies, and clean energy sources we will develop to survive on the moon or Mars can also be used to solve our problems on Earth. Space exploration doesn't just discover new worlds, it can also give us the technology and perspective needed to save our own world. Perhaps leaving home is the best way to appreciate it more, and to learn how to save it. You also experience this paradox. While admiring the possibilities brought by technological progress, you're also concerned about the damage this progress does to our planet. The flight to the moon is the embodiment of both of these feelings. It is both our greatest hope and a reflection of our deepest concerns. After all these discoveries, what do you feel when you look at the moon? On one hand, there is that deep awe and admiration in the face of the universe's unimaginable size and complexity. That sweet dizziness that comes when you understand your own smallness, that you're a tiny note in this grand symphony of existence. But, on the other hand, there may also be an anxiety that comes with all this potential, these resources, and new frontiers. The possibility of humanity repeating the mistakes it made on Earth on the moon. The fear of creating a new competition, a new field of exploitation. Perhaps you feel both, and that is completely normal. Because the moon is no longer just a celestial body. It has become a canvas for our collective hopes and fears, a mirror that reflects all the complexity, all the contradictions of being human. It reminds us of the heavy responsibility of being a species with the potential to both create a masterpiece and to destroy it. Proximity and distance, eternity and transience, silence and communication, preservation and transformation, success and failure. These paradoxes show that our journey to the moon is not just a physical one, but also a philosophical one. We now know that the moon is not just a geological object, it is a tool for understanding who we are. But, in this philosophical journey, there is one more question we need to answer, perhaps the most important one. After learning so much, after revealing so many secrets, what has changed? How should this knowledge affect our daily lives, our view of the world? Because the ultimate purpose of discovery cannot be just to write scientific papers or develop new technologies. The ultimate purpose must be to transform our consciousness. So how will this transformation happen? Because the moon gives us one last lesson, and this lesson is hidden in one of the most fundamental events in the sky, in an eclipse. That's why now is the time to ask the most internal question. And because the moon gives us one last lesson, and this lesson is hidden in one of the most fundamental events in the sky, in an eclipse. This event is about what knowledge itself means, and what we should do with this knowledge. Is this new consciousness we have gained by exploring the moon just an intellectual exercise? Or is it a power with the potential to make us better people? Because understanding what to do with this vast amount of information is a much harder journey than flying to the moon. This is a mental journey. And now, we are descending into the deepest layer of this journey. This journey first confronts us with the contrast between the overwhelming weight of knowledge and the impossible lightness of putting it into action. We know now, billions of dollars worth of helium-3 lies beneath the lunar surface. This could solve all our energy problems. But we still burn fossil fuels every day. We know that the frozen water on the moon could make us an interplanetary species. But We are still polluting the water sources on our own planet. We know that the pristine environment on the moon is invaluable for solving the secrets of the universe. But we're also making plans to turn it into a mining site. This is the tragic truth. Knowledge does not mean action. As humanity, we have the knowledge to solve our problems. But we're often incapable of turning this knowledge into collective action. This is like the paradox of a doctor who knows the dangers of smoking but still smokes. This is the greatest sadness that knowledge brings, knowing what the solution is, but not having the will to implement it. But the beautiful truth blossoms right in the midst of this impotence. Because our knowledge, even if it doesn't turn into action, is a seed. It is planted in the soil of consciousness and waits for the right time. Knowing that there is helium-3 on the moon may not change anything today. But 50 years from now, when an energy crisis is at the door, this knowledge could be a recipe for salvation. Knowing that it is possible to build a habitat on the moon may seem like a luxury today. But in the future, when we face an asteroid threat, this knowledge could be humanity's survival insurance. This knowledge sits quietly in a corner of our consciousness. It accumulates, and when the right conditions arise, it can turn into action with a spark. You also experience this paradox in your own life. You know you should eat healthily. But sometimes you eat that hamburger. You know you should exercise. But sometimes you don't get off that couch. But that knowledge is still there. One day, with a spark of motivation, that knowledge can turn into action. The situation is the same for humanity. This knowledge we have gained from the moon is potential energy accumulating in our collective consciousness. And one day, when this energy turns into kinetic energy, it can change the world. This situation leads us to a second deep contrast: the infinity of our curiosity and the transience of the answers we receive. We are a species that asks questions. What makes us one of the most fundamental features of the universe is our curiosity. We look at the night sky and ask, what's out there? This curiosity took us to the moon. This curiosity made us build telescopes, split the atom, and decode DNA. Curiosity is our driving force. And this curiosity is by its nature infinite. Every answer brings with it 10 new questions. We found water on the moon. But how did this water get there? We found a metal mass on the moon. But what exactly is this mass made of? We found rust on the moon. But does this rate of rusting change over time? This is the tragic truth. Our curiosity is infinite, but the number of answers we can get is always limited. There will always be something we don't know. The next puzzle, the next anomaly, will always be waiting for us. The moment we say, I understand, the universe will present us with a new puzzle. This is sad in a way. The sadness of never being able to reach absolute knowledge, the theory of everything. But the beautiful truth lies in this never-ending quest itself. Because what matters is not the destination, but the journey. What makes us human is not finding answers, but asking questions. What would we do if one day we had the answers to all the questions? Our curiosity would die, and when curiosity dies, the spirit of humanity would die too. That's why the universe constantly presenting us with new puzzles is actually the greatest gift it gives us. This means the game will never end. It means the adventure will always continue. And this is the most exciting guarantee of existence. You're also a part of this infinite curiosity. Remember the why questions you asked as a child. You found answers to some of those questions, but now you ask more complex questions. This quest is your personal journey of growth. And the journey of humanity is no different. We are the ever-young children of the universe, searching for its whys, and this is our most beautiful feature. And this quest leads us to a third contrast: the uniqueness of individual experience and the inevitability of universal law. The 12 people who set foot on the moon experienced one of the most extraordinary events in history. They were the first to see that magnificent desolation. They were the ones who saw the Earth as a pale blue marble from space. This was an extremely personal and unique experience that cannot be fully conveyed in words. But, at the same time, These astronauts were subject to the most ruthless and most universal laws of the universe: gravity, radiation, the deadly cold of the vacuum. The smallest mistake, the smallest leak, meant instant death. On one hand, they were the freest people in history. They were walking on another world. But, on the other hand, they were the most fragile and dependent people. Their lives depended on the calculations of thousands of engineers on Earth, the thin layers of a spacesuit and a handful of technology. Because this is the tragic truth. No matter how special, no matter how unique we are, we're all subject to the same physical laws. The universe does not care about our personal experiences or dreams. It operates according to its own rules. But the beautiful truth is hidden in the exact opposite. Yes, we're all subject to the same laws, but this is also what connects us to each other. Because certain these laws make us equal. An astronaut walking on the moon and a farmer ploughing his field on Earth are subject to the same law of gravity. We're all made of the same stardust. We're all children of the same universe. These universal laws are our common language, our common destiny. They are a unifying force that rises above our individuality and makes us part of a larger whole. You experience this dilemma every day too, with your own thoughts, dreams, and memories. You are the most unique thing in the universe. There is no one else like you. But, at the same time, you have to breathe, you have to eat, you succumb to sleep. Because you're also subject to these universal laws, and this does not make you alone. On the contrary, it connects you to everything that lives, to every atom in the universe. Knowledge and action, curiosity and unanswerability, individuality and universality. These deep thoughts are the philosophical lessons the moon offers us. They allow us to redefine our relationship with the universe. But these lessons also take us from abstract thoughts to a more concrete place. The question of what to do with this knowledge is not just a philosophical one, but also a practical one. Because our next journey to the moon will be very different from the Apollo missions. This time we're not just visiting. This time we're going to stay. And this requires a new set of questions and a new level of consciousness. It's because the next step is not just to understand the moon, but to learn to live with it. And that is a whole other story. Proximity and distance. Eternity and transience. Silence and communication. These paradoxes are the reflections we see in the mirror the moon holds up to us. They are redefining our place in the universe. But we are not the only thing we see in this mirror. Because when we look at the moon, we see not only who we are, but also the future potential of our species. And this potential holds a dilemma that is both exciting and frightening. Will the moon be a salvation or a catastrophe? Because the resources on the moon have the potential to solve our problems on Earth. But these resources also carry the potential to create new and bigger problems. And now, it is time to face this dilemma. Because the moon is not just holding up a mirror to us, it is also presenting a test. A testing ground for humanity's greed, wisdom, and ability to cooperate. The helium-3 on the moon could solve all our energy problems. But it could also spark a new Cold War over this resource. Countries and private companies are already racing to control this trillion-dollar treasure. This is both an opportunity that can unite us and a threat that can divide us even further. That's why going to the moon is not just a technological issue, but also an ethical and political one. This situation leads us to a fourth paradox: the pristine, virgin nature of the moon and our urge to transform and domesticate it. The moon has barely changed for 4.5 billion years. It is an untouched archive from the early days of the solar system. Every crater on its surface, every rock tells a story of billions of years. It is a cosmic archaeological site. For scientists, the preservation of this pristine state is priceless. Because some regions of the moon are so quiet and so protected that they could be perfect observatories for listening to the faintest signals from the universe. But here is the tragic truth. It is not in our nature to touch nothing. We change every place we enter. Our footprint on Earth is the greatest proof of this. When we permanently settle on the moon, when we start mining, we will inevitably change that pristine landscape. We will kick up dust. We will dig up the surface. We will make noise with our machines. We will break the silence of billions of years. This is the inevitable price of exploration. But the beautiful truth is hidden within this price. Perhaps it is our destiny to transform the moon. Perhaps it is our mission to bring life to that lifeless world, to melt that frozen water and grow plants, to light up those lava tubes and build cities. Perhaps the purpose of the universe is not for life to be trapped on a single planet, but to spread. You're also a part of this dilemma. You also experience this internal conflict. You want to both protect nature and benefit from it. On one hand, you admire the beauty of an untouched forest. On the other hand, you live in a house made from the trees of that forest. The moon takes this conflict to a cosmic level. Should we preserve it as a museum, or should we use it as a resource for our future? There is no simple answer to this question, and this brings us to the final and perhaps most important contrast, the act of flying to the moon itself. On one hand, this is the pinnacle of human intelligence and achievement. On the other hand, it is a reflection of our failures on our own planet. The technologies we developed to fly to the moon are the most concrete proof of what humanity can achieve. It requires hundreds of thousands of people to work together for decades, incredible planning, precision, and courage. The launch of a giant rocket like the Saturn V is a poem written in fire by the collective will of humanity. This is our best side, our curious, exploring, boundary-pushing side. However, the tragic truth also lies here. Is it possible that part of our motivation to go to the moon stems from a desire to escape the problems we've created on Earth? Climate change, resource scarcity, pollution. How ironic is it that we are searching for a new home while making our own planet uninhabitable? Isn't thinking of Mars or the moon as a plan B an admission of how much we have failed at plan A, which is taking care of our own home? This is a sad thought, but the beautiful truth is that this escape also holds the potential for a solution. The closed-loop life support systems, recycling technologies, and clean energy sources we will develop to survive on the moon or Mars can also be used to solve our problems on Earth. Space exploration doesn't just discover new worlds, it can also give us the technology and perspective needed to save our own world. Perhaps leaving home is the best way to appreciate it more and to learn how to save it. You also experience this paradox. While admiring the possibilities brought by technological progress, you are also concerned about the damage this progress does to our planet. The flight to the moon is the embodiment of both of these feelings. It is both our greatest hope and a reflection of our deepest concerns. After all these discoveries, what do you feel when you look at the moon? On one hand, there is that deep awe and admiration in the face of the universe's unimaginable size and complexity. That sweet dizziness that comes when you understand your own smallness, that you are a tiny note in this grand symphony of existence. But, on the other hand, there may also be an anxiety that comes with all this potential, these resources and new frontiers, the possibility of humanity repeating the mistakes it made on Earth on the moon, the fear of creating a new competition, a new field of exploitation. Perhaps you feel both, and that is completely normal. Because the moon is no longer just a celestial body, it has become a canvas for our collective hopes and fears, a mirror that reflects all the complexity, all the contradictions of being human. It reminds us of the heavy responsibility of being a species with the potential to both create a masterpiece and to destroy it. Proximity and distance, eternity and transience, silence and communication, preservation and transformation, success and failure. These paradoxes show that our journey to the moon is not just a physical one, but also a philosophical one. We now know that the moon is not just a geological object, it is a tool for understanding who we are. In this philosophical journey, there is one more question we need to answer, perhaps the most important one. After learning so much, after revealing so many secrets, what has changed? How should this knowledge affect our daily lives, our view of the world? Because the ultimate purpose of discovery cannot be just to write scientific papers or develop new technologies. The ultimate purpose must be to transform our consciousness. So how will this transformation happen? Because the moon gives us one last lesson, and this lesson is hidden in one of the most fundamental events in the sky, in an eclipse, And that is why now is the time to ask the most internal question. We have seen the secrets of the moon and how it illuminates our past. But I didn't tell you that this entire history of billions of years was actually written in the first 3 minutes, to those moments when the fate of the universe was decided, to those first moments when all matter, all laws were born. On our next journey, we're going to the most important 180 seconds of the universe. Are you ready?